The same AI model took the same coding exam twice this year. One run scored 93%, the other scored 77%. Nothing about the model changed. Same weights, same training, same knowledge. The 16-point gap came entirely from the software wrapped around it. That wrapper has a name now. Engineers call it the harness, and in 2026, it became the hottest skill in AI. Here is the experiment that proved it. LangChain took that Kirlian agent, which sat outside the top 30 on a brutal benchmark. The benchmark is Terminal Bench, 89 real terminal tasks, debugging, machine learning, infrastructure, the kind of work that breaks most AI agents. LangChain froze the model. They only rewrote the scaffolding around it. The score jumped almost 14 points, from outside top 30 to top 5. For comparison, upgrading to an entirely new model generation moved a similar benchmark about 7 points. The wrapper beat the model upgrade twice over. Researchers later measured gaps as large as 6 times on the same benchmark, from changing nothing but the harness. So what is this invisible layer that can double an AI's ability? First, you need to see what a model cannot do alone. A language model on its own is a brain in a jar, brilliant but blind, with no hands and no memory. It cannot run code, it cannot read your files, it cannot remember yesterday. Every conversation starts from absolute zero. The harness is everything that fixes this. The tools that let it act, the memory that lets it persist, the rules that keep it safe. Think of a Formula One car. The engine is the model, but an engine sitting on the pavement wins nothing. The chassis, the fuel lines, the telemetry, the pit crew, that is the harness. The engine only matters inside that system. In practice, a harness has layers, instruction files the agent reads before working, like a briefing document sitting in your repository. A tool layer for running commands, editing files, searching the web. A sandbox that limits the blast radius when things go wrong. State that survives between sessions, so the next run picks up where the last one stopped, instead of starting blind. And verification gates, tests, linters, and checks the agent must pass before its work counts as done. None of this is the model, which raises the question, who realized the wrapper mattered this much, and when? February 5th, 2026, Mitchell Hashimoto, the co-founder of HashiCorp and creator of Terraform, publishes a blog post. He describes a habit from months of working with coding agents. Every time an agent makes a mistake, do not just retry. Instead, engineer the environment so that exact mistake can never happen again. New rules, new checks, new guardrails, a permanent fix. He calls it engineering the harness. The phrase lands hard because thousands of engineers had been doing this without a name. 6 days later, OpenAI drops a field report that turns the idea into proof. 3 engineers, an empty repository in late August 2025. 1 rule, no human writes a single line of code. 5 months later, they had 1 million lines of production code and 1,500 merged pull requests, written entirely by their agent. That is roughly 3.5 pull requests per engineer per day. Their job was never writing code, it was building the harness. They even had the agent generate custom linters that block code from touching the wrong architecture layers, the harness enforcing itself. Prompt engineering peaked in 2023, context engineering rose in 2025. Harness engineering is the 2026 chapter. But naming a discipline is easy. The real question is, what harness engineers actually do all day? The core loop is simple and ruthless. Watch the agent fail, find the root cause, change the environment. The failure becomes impossible. It treats every agent failure as a system problem to fix permanently, not a prompt to retry and pray. Remember that 14-point jump from LangChain? Their recipe is a masterclass, and it starts with watching everything. Every action the agent takes gets traced and stored. Inputs, outputs, latency, cost. You cannot fix what you cannot see. They studied the failures at scale and found a pattern. Agents declare victory too early. They finish without checking their own work. So they built a checkpoint that intercepts the agent before it exits, forcing a verification pass against the swear against what was asked, not against what you wrote. Then fix and repeat. That one structural change, self-verification wired into the loop, drove much of the 14-point climb. Stripe went further and forked an open-source agent to build custom one-shot agents shaped around their own codebase. Different companies, same conclusion, and it leads to an uncomfortable idea about where the real value in AI now lives. Here is the twist. A recent study adapted only the harness and improved agents across 18 different model backbones. Read that again. Many agent failures are not reasoning failures at all. They are interface mismatches between the model and its environment. Another system improved pass rates by up to 21 points, over 130% relative, without touching a single weight. The model has become a pluggable component. You can swap it out. The harness stays, and the harness compounds. That is why some investors now call the harness the moat. Models leapfrog each other every quarter. A great harness is yours. So the 16-point mystery from the start was never a mystery. The score belongs to the system, not the model. The engineers who win this era will not write the most code. They will design environments where machines cannot fail quietly. Next time, how a 3-person team structures a 1 million line codebase that no human has ever read.